Welcome to yet another Juddy Productions video. In today's video, we'll be looking at Unit 3 General Maths, the area of study number 1, data analysis. Our topic is data transformations, and this particular video we'll be looking at the reciprocal of x transformations. We'll look at some example calculations and look at how a reciprocal transformation can possibly linearize data. So let's jump into it. So reciprocal transformation. First of all, what is 1? A reciprocal of a number is the value found by dividing 1 by that number. So for example, the number 2, its reciprocal is 1 over 2, or a half. The reciprocal of a number between 0 and 1 becomes larger than the original number, whereas the reciprocal of a number greater than 1 is smaller than the original number. The x reciprocal transformation involves compressing x values that are greater than 1 while stretching x values that are less than 1. Values closer to 1 are compressed or stretched less than numbers that are further away, and the y value remains the same. So here's a visual summary of what we've just described, where large x values are moved to the left and small x values are moved to the right. Consider the following sample data that represents the temperature in degrees Celsius of a hot cup of tea, which is allowed to cool over a time in minutes. So there's our data in the table. The tasks for today, first of all, for this original data, task number 1, we want to enter this data into the TI Nspire CAS calculator. Number 2, we want to perform a linear regression and record the y-intercept, the slope, the Pearson's correlation coefficient, and the coefficient of determination. Number 3, we want to describe the relationship between the variables. Number 4, we want to determine the least squares regression line. Number 5, we want to generate a scatter plot using the TI Nspire CAS calculator. Number 6, we want to generate a residual plot also using the TI Nspire CAS calculator. And finally, number 7, we wish to perform a residual analysis. So let's use the CAS calculator to perform these particular tasks. Okay, we open a list in spreadsheets and we put the heading of time and we fill that data in for the minutes. And our second heading is temperature in column 2, and that data is placed in as well. We then go to the menu, statistics, stats calculation, and linear regression of the form a plus bx. Our x variable is the time, and our y variable is the temperature. Press OK, and we have all the information we need for a linear regression, from the a to the b to the r squared to the r. We can now plot this on the vertical axes. We like temperature, and on the horizontal axes, we would like time. It's a curvy shape. Doesn't look linear. We go to menu, analyze, regression of the form a plus bx, and there's our straight line equation. Not really following the data that well though. We go to analyze, residuals, and show residual plot, and there we see the smiley face residual plot. Task number 2, perform linear regression. So as a summary, we can see that the y-intercept had a value of 56.347, the gradient had a value of negative 3.781, the Pearson's correlation coefficient, that is the R value, is negative 0.8066, and the coefficient of determination, that is the R squared value, is 0.6507. Task number 3 was describe the relationship between the two variables. So we can see that with an R value, a Pearson's correlation coefficient being negative 0.8066, this is still a strong association or a strong relationship. The direction is negative because the Pearson's correlation coefficient has a negative number, and the form from the graph we can see it appeared non-linear. Task number 4 was determine the least squares regression line. So that was found to be the temperature in degrees Celsius is equal to 56.347, take away 3.781 times the time in minutes. Task number 5 was to generate a scatter plot, so that's what it looked like, clearly not linear. Task number 6 was to generate a residual plot. So task number 7 was to perform a residual analysis. So looking at the residual plot, we see it displays a clear pattern. The residual plots are positive, negative, then positive again, much like, if you like, a smiley face. This plot does not support the assumption of a linear relationship between the variables. It may be possible to linearize the data by applying a transformation to one of the two variables. So let's do that. Let's apply a transformation, a reciprocal transformation, to the x variable, that being the time variable. So we're going to repeat this activity using the reciprocal of x, that is the one on time transformation. So I have a table here with the original values of time in a ghosted grey colour, and I've included in this new table the reciprocal of time, the one on time. And we calculate those values by dividing 1 by the time in minutes. So the higher the time in minutes, the smaller the value of 1 on time, the reciprocal. And the temperature, of course, is in degrees Celsius, is the same as the first table. We're going to repeat the 7 tasks that we did with our original data, but this time with our transformed data. So number 1, we want to enter our data on the TI Nspire. Number 2, we want to calculate the intercept, the slope, the Pearson's correlation coefficient, and the coefficient of determination. Number 3, we wish to describe the relationship between the two variables. Number 4, we wish to determine the least squares regression line. Number 5, we want to generate a scatter plot. Number 6, we want to generate or produce a residual plot. And number 7, we wish to perform a residual analysis. And finally, we want to compare the original data against the new transformed data and see if this has in fact linearized our data. So let's do this on the TI Nspire CAS calculator. We open a list of spreadsheets. We go to our first column and we give it the heading time in minutes, and that will fill. Our second column we're going to call reciprocal underscore of time. This is our transformed x variable. And to fill this cell in, we type in the equal symbol, and then we label it time, and we raise it to the power of -1, which is the same as 1 divided by time. And that will load all the cells in that column with the reciprocal of time. Then our third and final column will be temperature, which we've loaded previously. We now go to the menu, stats calculation, and a linear regression of the form a plus bx. The x variable this time is the reciprocal of time, important, and that of y is temperature. And there we have our regression data of a, b, r squared, and r. We now look to plot this. On the vertical, we want temperature. On the horizontal axis, we don't want time, we want the reciprocal of time. That has linearized the data nicely. We go to menu, analyze, regression, and we want to show the linear equation of a plus bx. And then finally, we want to analyze the residual plot. Task number 2, let's look at our linear regression data. So for our transformed data, that is the time reciprocal transformation, we have a y-intercept of 20.561, a gradient of 51.176, a Pearson's correlation coefficient of 0.9998, and a coefficient of determination of 0.9995. Task number 3, we're asked to describe the relationship between the two variables. We can see the Pearson's correlation coefficient has a value of 0.9998, nearly a perfect 1. And that's on the far right-hand side on our scale here. So that represents a strong positive linear association or relationship. And the form is linear because we've seen the transform graph. Task number 4, we're asked to determine the least squares regression line. So that was found to be the temperature in degrees Celsius is equal to 20.561 plus 51.176 times 1 over time. That's the reciprocal of time, where the time is measured in minutes. Task number 5, generate a scatter plot. So there's our nice linear temperature versus the reciprocal of time scatter plot. Task number 6 was to generate a residual plot. Task number 7, we want to perform a residual analysis. So looking at the graph under task 6 of the residual plot, we can say that the residual plot displays approximately equal numbers of points randomly scattered above and below the horizontal axes. No clear pattern is displayed. That is, it's not a smiley or frowny face. This plot supports the assumption of a linear relationship between the variables. This is the correct transformation for this particular set of data. Finally, let's make a conclusion comparing our original data to our new transformed data. So there's our original data with the least squares regression equation, the scatter plot, and the residual plot. You can see I have a very high R correlation. It is greater than 0.75, so it's high. We have an R squared value of 0.6507. However, when we look at our residual plot, the original data probably have a nonlinear relationship. The residual plot does not support the assumption of the linearity. Transformation of the data may be required, and a least squares regression line should not be fitted to data that is not linear, as any interpretations or predictions will not be accurate. So we then use our reciprocal of x transformation. So we determined the least squares regression line, and we also plotted the scatter plot, and we also plotted the residual plot. From this, the following summary was achieved. We have improved our R value from an original value of negative 0.8066 to a new value of 0.9998. We have drastically improved our R squared value from an original data value of 0.6507 to a new improved 0.9995. The reciprocal X transformation has improved the original R and R squared value, and we look at our residual plot. We can state that the reciprocal transformation has linearized the data. This is the correct transformation for this particular set of data. And the temperature in degrees Celsius is equal to 20.561 plus 51.176 times the reciprocal of time in minutes. This is the best relationship available for these two variables.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.